Okay, good afternoon class. So today we're looking at analytical geometry, looking at the mixed examples. Okay. So at this point we have dealt with all the formula. Now we're just using those formulas in these mixed sums now. Okay, so we're looking at the examples for exercise 4.6 and 4.6 on page 100. Is that correct? 103. 4.6 on page 103. Okay. Even this is example 1 and example 1's on page 100. Okay, so here we're told the vertices of triangle. Now the vertices are the endpoints of a triangle ABC are A, which is 4 and 3, B, which is -1 and 7, and C, which is 2 and -5. The question says, determine the coordinate of T, the midpoint of AC. Okay, so this is number 1, or is it A? It's A. So they want you to work out the midpoint. So what is the midpoint formula? x1 plus x2 over 2, y1 plus y2 over 2. Not so. There we go. We say x1 plus x2 over 2, y1 plus y2 over 2. Alright, so if we make this x1, y1, this of course going to be x2, y2. Which is now simply t is going to be 4 plus 2 over 2 and 3 plus -5 over 2. So t is 3 and that's going to give you -1. Is that correct? And it should make sense to us, people. That's the nice thing about analytical geometry. It will make sense. Okay. So that's A. Look at B. In B, we are asked to calculate the equation of the straight line BT. The equation of the straight line BT. So the equation of the straight line will be in the form of y equals mx plus c. So how do we calculate m? Your gradient, which is y2 minus y1 over x2 minus x1. You all agree with that? So if that is x1, y1, this is of course x2, y2, or vice versa. Alright. So let's go. Y2 is of course -1 minus 7 over 3 minus -1, which is -8 over 4, which is -2, which confirms the slant of this graph here. Can you see the graph is a decreasing function? Can you see that, people? So the gradient has to be negative. So my equation reads now y is equal to -2x plus c. So how to calculate c? We either substitute b or t. So we'll substitute t, which is 3 and -1. If your gradient is correct, then b should give you the same answer. Okay. Remembering that's an x and a y, so -1 is equal to -2 times 3 plus c. It's -6, you bring it over, it's 5 minus 1 plus 6 is 5. And there you can see that you normally y-intercept it. So y is equal to -2x plus 5. And we can test it. We put -1 in here. What's 2 times -1? It's 2. 2 plus 5 is 7. which still confirms that we are correct. Right. Any confusion there, people? Let's look at C. And all what we've calculated thus far is on the diagram. See, they ask you to work out the length of AB. Well, how do you work out length? Distance formula, not so. Let's go. See, distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. People, you guys must learn this for the exam. Okay? So that will be the square root of x2. So it's going to be of AB. So let's make this x1, x2, y2. As we already have x1, y1 there. That would simply be x2, which is 4 minus 1 squared plus 3 minus 7 squared. Alright, let's put that in the calculator. That's going to give you 25, and that is 16. 25 plus 16 is 30, 41. So it's 5 squared plus 16. 41, the root 41. And the question says leave it in third form, and that is third form. People say any confusion? Huh? Any questions? There are only 3 questions pertaining that diagram, no? I need to check if I made no mistakes there. 41. Right. Let's now go to example 2. Example 2 is on page. Sorry? 101. Example 2 is on page 101. So the vertices of triangle PQR, where P is 3 and 5, Q is negative 1 and negative 4 and 1, and R is 4 and minus 3. Determine. What you notice here, people, I always read this information here. Okay, sometimes there's information on this diagram, or in the opening statement that's not on the diagram. Okay? So importantly that I read that information. First question says, A says the gradient of QR. Calculate the gradient of QR. People, how do you calculate gradient? Change in Y over change in X. The gradient of QR is going to be Y2 minus Y1 over X2 minus X1. Make a habit of writing the coordinates you're using on the side here. We've got negative 4 and 1, and R of course is 4 and negative 3. That's x1, y1, x2, y2. Okay. So y2 is what? Negative 3 minus 1 over 4 minus 4. So QR is this length here. What do you notice about QR? It is positive or negative? Negative. So it's going to be negative 4 over 8, which is negative half, which confirms what we initially said. The gradient of QR is negative half. Okay, is there any confusion there? No? B. B says calculate the equation of PS. So if you're looking at PS is perpendicular to QR. People, if lines are perpendicular, what do we know? The product of the two gradients is negative 1. Okay. The product of the two gradients is negative 1. So what would the standard form of this equation be? Y equals mx plus c. So gradient 1 times gradient 2 is equal to negative 1. So if the gradient 1 is negative half, the gradient 2 will simply be negative 1 divided by negative half, which is 2. So what's my equation now? Y is equal to 2x plus c. Now in order to calculate the c value, I need a point that's lying on the straight line, which is PS. And we know that P is lying on PS. What's the coordinates of P? 3 and 5. So in other words, we'll substitute P, which is 3 and 5. Remembering that's an X and a Y. Okay. Let's go with that now. So this will simply be 5 is equal to 2 times 3 plus c. That gives you an answer of 6. So it's 5 minus 6, which is negative 1. My equation is y is equal to 2x minus 1. Alright, any confusion there? Very simple, no? As long as you have understood everything of exercise 4.1 to 4.5, this should be simple. Okay. We're now looking at example 3. Example 3 is on page 102. Okay, so here we are told that in the diagram, A is a point 0 and 5, B is a point 8 and 5. The equation of AC is, you see this, okay, it's also on here. AC is y is equal to negative 2x plus 5, whilst BC is negative 2x minus 11. AC and BC intersect at C. Okay. First question, determine the coordinates of C. People, how do we normally work out the points of intersection? See the two equations equal to each other, not so. Or we do what we call simultaneous equations. Okay. So the one equation is y is equal to negative 2x plus 5, and the other one is y is equal to negative 2x minus 11. So what we do is do simultaneous equations. So y is equal to that and y is equal to that, therefore minus 2x problem here. The gradient is wrong here. You see, this is a positive gradient, you got negative 2x here. Okay, there's a typing error there. Can you see that, people? You got 2x minus 11, yes, negative 2x minus. Can you see the problem? Okay, so we'll just change that. There we go. So the one equation is y is equal to negative 2x plus 5, and the other one is y is equal to 2x minus 11. So what do I do? Simultaneous equations, so we set the graphs equal to each other. So negative 2x plus 5 is equal to 2x minus 11. X is one side, numbers are the other side. So negative 4x is equal to negative 16. X is then equal to 4. You see that? Which makes sense, people. If that is your 8 there, then I would expect C to be anything between 0 and 8. You see that, people? Then it's now dead center there. How do you calculate the corresponding y value? You can either sub that either into the equation going through the line going through AC or the line going through BC. Because it's the same, it's the point of intersection here, the y value will be the same. Alright, so it's going to be negative 2 into 4 plus 5, which is negative 8 plus 5, which is negative 3. Which also makes sense. It's on the negative part of your y-axis. You guys understand? So therefore, C would be 4 and negative 3. Or if I've gone with this one here, it's going to be 2 times 4, which is 8. And 8 minus 11 is also negative 3 anyway. Okay, let's look at B. Okay, so the B part of the question says calculate the size of theta, the inclination of straight line BC, connect to one decimal place. People, how do we calculate the angle inclination? We say tan of theta is equal to the gradient of that line, which is BC. Can you see that, people? It's against here, so it's to do with this line here. So what is the gradient of BC? 2. So tan of theta is equal to 2. So arctan of 2, give us an answer. Arctan of 2, 63,43. Okay. See any confusion there? 63,43. Also note I'm populating this diagram as I go along. Alright. Look at C. Show analytically. So we were talks about analytical methods. Then I must use midpoint, distance, gradients, lines of parallel gradient, and so on and so on. You guys understand? So if we must prove analytically that AC is equal to BC, I start off by working out the distance of AC. Okay. Do not open with the opening statement saying that AC is equal to BC. We must conclude that AC is equal to BC. You guys understand? So what's my formula? So this is AC. So the coordinates of A again is going to be 0 and 5. And the coordinates of C is 4 and minus 3. That's x1, y1. This will be x2, y2. This is my formula. x2 minus x1 squared plus y2 minus y1 squared. So it's going to be x2, which is 0, minus 4 squared plus 5 minus 3 squared. It's 8 and 16. 8 squared is 64 plus 16, so the root 80. So it's, comes down. Okay, so it's going to be root 80, 16 is 4 root 5, I think. You just check. So it will be 4 squared plus 8 squared. 4 root 5. Okay, so if I can prove BC is also 4 root 5, I've done the job. Not so. So BC, we go BC. Do I need to write the formula down again? No. No. So B is 8 and 5. And C, of course, is 4 and minus 3. Okay, so if I make this x1, y1, that will be x2, y2. So we go. X2, which is 4, minus 8 squared, which is 4 is 16. And then negative 3 minus 5 squared, which is again 8 is 64, root 80, which is 4 root 5. So what do we say now? We can conclude now. Not so. Therefore, AC is equal to BC, which is equal to 4 root 5. Will you guys understand? Is there any confusion there? Again, look that if they show analytically that is equal, I've ended with the fact that they are equal. Okay. Let's look at D. This is the determine the coordinates of P, the midpoint of AC. We just put in this information here. So BC is going to be equal to AC, which is equal to 4 root 5. Okay. So the coordinates of P, the midpoint of AC. People, people, how do you work out the midpoint? Using the midpoint formula, which is what? x1 plus x2 over 2, y1 plus y2 over 2. So which coordinates do I use? A, which is 0 and 5, and C, which is 4 and minus 3. You all agree with that? So if that is x1, y1, this would be x2, y2. So P would simply be x1, which is 0 plus 4 over 2, 5 plus negative 3 over 2. 4 over 2 is 2, and that is going to be 2 over 2, which is 1. Okay. So any confusion there? No? You guys following if I'm making any mistakes? So I'm on the right track so far. I feel better about myself. And then of course the last question. We are asked to determine the equation of the perpendicular by sector of AC. People, if something is perpendicular, what do we know? The product of the two gradients is negative 1. So it's the perpendicular by sector of AC. So perpendicular is a line going through like that at 90 degrees. Bisector means to say, wait, what? It's cut in half. So it's actually this dotted line that they're wanting you to calculate. You guys understand? So, did we work out the gradient of AC already?
Yes.
Oh, here's the gradient. It's given negative 2. Not so. So we know that gradient 1 times gradient 2 is equal to negative 1. So the gradient 1 is going to be negative 2 times gradient 2 is equal to negative 1. So the gradient of the perpendicular bisector is what? Negative 1 divided by negative 2, which is half. Which confirms, can you see that's the increasing straight line graph? The increasing linear function. Can you see that, people?
Yes, sir.
Right, so what's my equation? Y equals mx plus c. What's your m value? Half x plus c. So in order to calculate c, I'm going to substitute a point that's lying on this purple line. Do I have such a point? Yes. Which is what? 2 and 1. So we're going to substitute 2 and 1. I can only substitute the point that this graph is going through. So it's the x and the y. So 1 is equal to half times 2 plus c. So half times 2 is 1 and 1 minus 1 is 0. So therefore my equation is y is equal to half x plus 0. Y is this equal to half x. So this line here is actually going through the origin there. How do I know that? Because your c value is 0. Your c value is normally your y-intercept there. Alright. People, any confusion there? Alright. Did anybody start with exercise 4.6? Sorry? Sorry? Was it homework? Okay, so was there any issues with 4.6? Let's check there quickly. Sorry? So you had to do 1, 3, 5. So there was no issues with 1, 3 and 5. Right, for homework is the remainder of that exercise, which is 2, 4 and 6. Which will be good for you is if you can do before the exam, which starts next week, to do the revision exercise as well. Okay, just to ensure that you're going to get at least 90% for the section of work. It's fairly simple. No? The full lesson can be found in the description box. Yes? No. Okay.